Okay, welcome to the Wave Mechanical Model. You should have just got done taking your quiz. Hopefully that was a joyful experience. We're now going to talk a little bit about the Wave Mechanical Model. This is the current model of the atom today based on all the information we found through the different experiments. We'll wrap up this and we'll talk about electron configurations today. Make sure you follow along and you pay attention. If you have questions, ask the sub to rewind it or make a note and you can ask me when I come back on Monday. On Monday, we will grade everything in your lab book, so make sure you have as much of your homework done as you can. I will give you a little bit of time on Monday to work on that. Also in your lab book, we will not be doing the lab book Beanium. So if you missed the Flames Away lab, make sure you go to the blog and get that made up. And Wednesday is your test. Friday, we'll do the binder check, and we'll be out of here for the holidays. So let's start with the wave mechanical model. Okay. So 1924, Louis de Broglie proposed that electrons have the properties of waves. Okay, that was a major paradigm shift because we'd always thought of electrons as these little tiny particles, but now he's saying, well, they're going to actually behave like the waves that we've looked at. He got that idea kind of from Bohr's model of the atom. Okay, then Heisenberg developed the uncertainty principle. And yes, my spelling may be off. It's okay. Deal with it. Okay, the uncertainty principle, when applied to electrons, states that it is inherently impossible for us to know simultaneously both the exact momentum of an electron and its exact location in space. So basically we can say how fast it's going, but then it's going to be moved, so we don't know where it's at. Or we can say where it's at, but then we don't know how fast it's going because we have to say it's stopped. So we can't do that together. And then along comes Erwin Schrödinger, a freaking genius. I will have to show you his equation that he came up with, but he's quite the mathematician. And he proposed an equation that incorporates both the wave-like and particle behavior of an electron. This is known as a wave function. So basically he did an equation and said, if you've had calculus, parabolas of where the electron is located. Okay, so these three scientists, Broglie, Heisenberg, Schrödinger, all helped to develop this model of the atom. They said that an electron will behave like a wave, that electrons and atoms have certain specific energies, and that electrons are arranged in certain energy levels. Okay, so those levels, remember, if an electron moves up and it falls back down, it gives off light or photons. Now, let me just move down a little bit here. Okay, electron location can be described as an electron probability cloud. So, well, that was probably loud in the mic. I'm sorry. Okay, electron location can be described as an electron probability cloud. So we can say that we have a really good chance of finding the electrons in a certain place, but we cannot say exactly where they are. So, now you have two questions here at the bottom, and then we'll draw some pictures. Basically, why was the wave mechanical model of the atom developed? So, why do we develop something new? Well, we change our ideas in science when we get new information. We got new information from the test, and then we had to adapt and adjust our model. Remember, science is not set in stone. It's constantly changing as we get new information. That's a key. Okay, and because electrons behave as waves, they move in different patterns. Now, for most of your life, you've probably been taught that the atom looks something like this, with a nucleus and electrons orbiting around that. That's wrong. It makes a nice visual, but it's not really how it looks. Electrons are going to look more like this. Okay, so we have the nucleus. The nucleus is made up of protons and neutrons, and it's very, very dense. That's why I'm coloring it so dark. Okay, that's the nucleus. Now, around this nucleus, we have what is called the S cloud. And that's a sphere. Sorry, it doesn't really look like one, but it is. It's spherical in shape, meaning that the electrons can be anywhere in that area. Okay? Anywhere there. Okay, they're going to want to be in that area. This is a low energy level. Then we have, sorry, I didn't want that color. I'm trying to adjust my colors here. The P cloud. Okay, so we have the S cloud, which is in red, and the P cloud looks a little bit more like this, with these different lobes. Again, these are the probability clouds that came from Schrodinger's equation. So now we can say, okay, the electrons are going to be right there. Maybe they'll be there. Maybe it'll be here. Maybe it'll be there. Maybe there. Maybe there. Odds are you're not going to find it right there, but you could. But it's about maybe a 1 in 100 chance you will. The best bet to find the electrons are in the different clouds. Okay, we call this the wave mechanical model. There's other clouds. We have an S orbital, we have a P, a D, and an F. These shapes get really complex, so we won't be doing much with those shapes in here, but just know that they exist. But the S and the P are just probability clouds where we can find them. Now, with that knowledge, we can go into electron arrangements, which basically give us the location of the electrons. Electron arrangements tell us where the electrons are located in the atom. And one key for you to know is that electrons always want to be in the lowest possible state. They're like us, they're lazy, they want to be low energy. Okay, so hopefully you've learned here that this is the current model of an atom, right there, not this, and that electrons are in probability clouds, they're not in defined orbitals. On your test, you will have to know like what the S looks like, what the P looks like, and more information about those as we proceed. Cool. Thanks for listening. Your sub's now going to change it to the second video. The second video will take place on page 18, so you want to be turning to electron arrangements. Peace.